morning. Happy Thursday, June 11th.
Good
This
morning.
is your second to last week of school. 3 more days after this. Great topic, not too difficult. Today, our goal is to be able to determine the area of a shaded region. So last week, or even this past week on Tuesday, we learned area formulas. Area of a circle, area of a triangle, area of a trapezoid, various shapes. And if you look here, Mrs. Talhami has this so nicely laid out. All we're doing is taking the whole and we're subtracting the whole.
So sometimes you might have to do, sometimes you have to do the whole shape. You might see more than one shape here. Some of you might recognize here the whole entire thing, this whole entire outside shape. Some of you might recognize it right away as a trapezoid. Others might say, hey, wait, I have a square and a triangle. So you could either break it into two shapes, or you can figure it out as one whole shape. It really depends on what is given to you.
When I look at that, Mrs. Talhami, I immediately see a square and a triangle, only because it's labeled the square 10 in the base of the triangle, but it would probably be much faster just to use one simple trapezoid formula.
Yeah, absolutely. Either way, it could work. So here, let's just finish labeling all parts of this square, so it'll help us. So a trapezoid's formula, if you remember, a trapezoid is similar to the triangle, where triangle is 1/2 base times height. So a trapezoid is 1/2 sum of the bases times the height. So here, our two bases are the 10, and then this total base, which is 10 plus 7, so that's 17. And then the height is the distance between those bases, which is 10. So we have 1/2 17 plus 10 times 10.
And when you do that, you get 135.
Good. So you get 135 is the area of this whole entire thing. So if I were to color in this whole thing, then I get 135. Now the
centimeters squared.
Exactly, centimeters squared. Now if we want to get just the region that was shaded originally, I need to get rid of this circle to get what was left. So if I get rid of this circle, I'm left with this purple area. So our goal is to find out what the area of the whole is, which the whole is the shape of a circle, and we have to subtract them. So a circle is pi r squared.
Now pi r 2.
Yep. And here, if I think about this whole distance is 10, so a radius would be 5. So we have pi r squared. So this is 25 pi centimeters squared. So my last step is the whole thing minus any holes. So my area of that shaded region, this green piece that's all right here, all this area that they're looking and asking for, is the 135 minus the 25 pi. Now if it asked for an exact answer, that would be a correct exact answer. If it asked for us to round, Miss Murphy, what would be the best place to round to right now?
It would be 56.5 to the nearest tenth.
So this is approximately 56.5 centimeters squared. So that's to the nearest tenth. So really, that's it. That's how you find the area of the shaded region.
So when we leave pi in the answer, the directions would say something like leave your answer in terms of pi, and that would be the boxed answer.
Sometimes, yep, sometimes they would say leave it in terms of pi. Sometimes they just say determine the area of the shaded region. They won't specify for you to round. So if they do not specify rounding, then you don't round. Only if they say to the nearest tenth or hundredth or to the nearest square centimeter, which is a whole number, do you have to do that rounding. So let's see.
So let's just peruse through some of the examples below. I think 1 is easy. 2 is just a rectangle minus a circle, right? If we put those two semicircles together, we'd have one full circle. 3 is a circle minus a circle. 4 looks like a circle minus a square.
And those are examples. I think the hardest example, if I look at these 4 questions, Miss Murphy, and you might not see it right away, but I think number 4 is a challenging one, only because you will find that you don't have all the dimensions you need as easily.
So maybe we should do that one together.
Okay, so then we'll do that one together, and they'll complete the remaining 3. So let's do the whole thing right now. The whole shape, if I focus on what the whole thing is, it's a circle. So we need pi r squared. Now if you look at this, the radius is right here, but it's not given to us. So we have to determine the radius. We only know that this is 12, that these are all 12. So I'll label that. We'll need that maybe for later. But then if I take a look at this, I need to figure out what the radius is. Now, my trick is if I draw another radius this way and just focus on this shape right in here, I now have an isosceles right triangle because diagonals in a square are perpendicular. That's a property from the rhombus, and a square is a rhombus. So since I have a right triangle, that means this is a 45, 45, 90. So I'm going to pull that over here for a second. So my rules for that is x, x, and then this is x rad 2. So this is where the challenge comes into place. And this is where I'm going to help you. If x rad 2 equals 12, that means to find out what each x is, I have to divide by rad 2. So I get x equals 12 over rad 2. Now the only thing about this, in math, we are told we could never leave an irrational number in the denominator like this. So I'm going to do something called rationalizing the denominator. So this is something a little bit more challenging, but I will complete it with you. So I multiplied it technically by 1 because these are both the same. So I get 12 rad 2 over the square root of 2 times the square root of 2 is the square root of 4. Square root of 4 is 2. So really this simplifies to 6 rad 2. So I did the math here for you, so you don't have to worry about it. That's why I felt that this was going to be a challenging question. So x is equal to 6 rad 2. Really, that was the hardest part of this problem. The rest of this problem you can finish from here, but I'll help you do it. So pi 6 rad 2 squared. So 6 rad 2 squared, oops, is 72. So we have 72.
Oh, I was going to say that.
72 pi. And then minus the wholes, which is a square. So it's base
Which
times
is
height. So here is
144. 12 times 12 is 144.
So my final area would be 72 pi minus the 144. Very important that you keep it in the correct order, because 72 pi, even though it looks like it's a smaller number because 72 is smaller than 144, 72 pi is actually, the value of this is larger than 144. So this is my exact answer right here. But if I were to round it, it's about how much?
82.2 to the nearest tenth.
So if I had to round, there's my answer rounded. So the remaining three are a lot easier than that. We just went through number 4 because of how challenging those numbers were. I think if you pause the video here and make sure you stay consistent with whole minus wholes, then you should be able to complete this with no problem.
See you in a few.
Okay, so hopefully by now you were able to complete the practice problems. And let's see, check your answers.
So look at number 1. You have a square minus a circle. Notice that the radius is half of the diameter. That's why it was 3. And your exact answer in terms of pi, or to the nearest tenth, 7.7. Number 2, we had a rectangle. Now we know that opposite sides of a rectangle are congruent. So in this particular case, it would be fair to say that we have 2 congruent semicircles, 2 half circles, which is the same thing as saying that we have 1 circle. But be very careful, because not all pictures will give you exact semicircles. Look at the case here, where you have a much larger semicircle and a smaller semicircle. So don't always think you can combine them and just use one full circle area formula.
It only,
Here
she makes a great point. It only works here in this problem. A half a circle plus another half circle will make 1 full circle, but only if they're the same. In this side example that I just drew, here's a half circle and here's a half circle, but I would have to find them separately because they're not the same half of a circle.
Excellent. Okay, so your exact answer in terms of pi is 60 minus 9 pi centimeters squared, or to the nearest tenth, 31.7 centimeters squared. And the last one that you did on your own, you have a whole circle minus a smaller whole circle. And so the larger whole circle, we would actually have to combine the 2 and the 1 to give us the full full radius, okay, which is 3. So 3 squared is 9, giving you 9 pi. And then that smaller pink or red circle only has a radius of 2. 2 squared is 4 pi. Now, notice that when you have 2 answers that are both in terms of pi, it's like having like terms. You can combine those this time. 9 pi minus 4 pi is 5 pi, only because those are like terms. And 5 pi to the nearest tenth is 15.7 centimeters squared. All right. I hope you did well with that. Please go and do Castle Learning. You have only 3 more after this. Good luck. We're here if you need us. Email or Schoology. Take care. Have a great weekend.
Bye, guys.